Wrapping up our focus lessons of the first 5 lessons, which is dealing with equivalent ratios. So we're going to be given ratio problems here, and we're going to be using the idea and concepts that we've done 1 through 4 and wrap them all together here in lesson 5 to understand equivalent ratios. Now, I need you to make sure that your headphones are plugged in, that you're listening. Once again, that means that you are hearing and your brain is engaged and that your pencil is in hand so that you can take notes. If I write it down and I'm showing you a step, then I expect that to be seen in your book. Once again, when you're finished, then you're going to get an assignment. If you're having trouble, then please come and ask and I will walk you through it and explain it to you again. However, if you haven't taken notes in your book like I asked, then you weren't trying to learn the lesson and I'll just have you come back and redo the lesson. So please be prepared to take notes. There are a couple extra notes, and if you want to use Post-its like I show on the slides, then back there on my back desk, you can get some Post-its and feel free to use those at any time. Here we go. So as we're going through this, and once again, we want to know what our goal or objective is, and that once again is our I can statement. It says I can solve real world problems, and that's my entire goal always and forever when it comes to math, is being able to apply that in any situation in life to where I understand it. And they talk about a couple different ways that you can do that with bar diagrams and double number lines and equivalent ratios. And we're going to focus in on equivalent ratios, and I'm going to show you 2 processes that will always work. I find one to be easier because I can then use that in a variety of different math problems. So as we're going through this, and then please pay attention and follow along. So this one is talking about bar diagrams. It says, suppose 3 out of 5 randomly selected students at a certain school play sports. There are 525 students at the school. You can create a bar diagram to predict how many of the students play sports. So the bar diagrams are all those illustrations that they're showing you that I'm covering up. Because in my opinion, all of those bars are going to confuse you more than anything. The main idea of math is being able to think. Thinking and applying, does it seem logical? That's the key to truly being a good and strong math student. So when I start with this problem and I see that I have 3 out of 5, then I should ask myself, well, what does that look like as a ratio since we are talking about ratios? And 3 out of 5 would simply look like 3 to 5. And we know that when it comes to ratios, we can write ratios in 3 different ways. Usually, we use that fraction form because that's how we're going to apply it and set up a math problem. So as I'm looking at it and the information they gave me, I can see that 3 are going to play sports out of a total of 5 students that are questioned about it. So thinking about what is being said, thinking about the information that's given, and thinking logically about it is the key to being a good math student. And I will always explain to you how that happens if you truly pay attention to the lesson. So we're going to look at the bar and what they're trying to tell you. And I don't want it to be confusing because sometimes it is beneficial to draw a picture. There are times when I'm doing math that I draw myself a picture so I can visualize it. So I'll explain to you what this bar process is all about. So if we just draw a bar, right, we're going to say that that's going to be the total amount of number that we're talking about. So in this particular case, I have 525 students. So one bar, it doesn't matter how big or small it is, as long as you can break it up into smaller groups. That one bar is going to be equal to 525 students. When I look at my ratio of 3 to 5, my denominator of any fraction or ratio is always going to tell me how many groups my total is divided into, meaning that that one bar has to be put into 5 equal groups. When it's put into 5 equal groups, then I have to focus in on what I'm talking about, which is 3 out of that 5 are going to participate in sports. So if I have 3 out of 5, then that's what this diagram is showing you. I take the bar for the total number of students, I divide it into 5 equal groups, but I'm going to focus in on just the 3 groups that play sports. So I get all of that information just from reading those word problems. And if you need to have the visual, then please, by all means, have the visual. When I'm doing it and I'm seeing that I have a ratio, then I'm visualizing in my head. I'm like, okay, I know I have 525 students. They're going to be put into 5 equal groups, but I'm only going to focus on 3 of those groups. So I know I have 3 to 5 to set up my math problem. And then it tells you mathematically, well, if I can divide by 5 and get 105. So how's that happen? Well, let's review our steps of division. So if I know I have 525 total and I need to put it into 5 equal groups, then I need to see how many are in each of the groups. So 5 goes into 5 one time because 1 times 5 is 5. That gives me a 0. I bring down my 2. Now here's a note that some of you really need to write down. Please don't just type it into the calculator and you know that it's 105, or look over to the left and you know it's 105. I need you to understand that when I'm dividing, if I bring something down, no matter what, I have to bring something up, right? So if something comes down, something has to go up. And I'm asking myself, how many times will 5 go into 2? Well, that answer is 0. So please make sure you take this note that anytime I'm dividing, if something comes down as I'm working through my division, I have to have something go up. It's either a 0 or another digit. I can't just bring down 2, 3 things at a time and not have something holding those place value, because there is a huge difference between 105 and then me saying, well, I don't need that 0, so it's just going to be 15. That's definitely not the same amount. So once I have my 2 brought down, I bring up my 0. Now I want to bring down my 5. And then I ask myself, how many times will 5 go into 25? And that is 5. So that's how we know that there are 105 students in each of the 5 equal groups. Okay? Once I do that, then we know that we're going to use 3 of those groups. So we're going to take the 105 and multiply by 3 to see how many total we're talking about in this scenario. So we have 105 times 3. That gives me my 315. And then my label would be play sports. We can't just put students because the 525 is also students. Now, if you want to be specific and put students play sports, that's fine. It's no extra credit, but I need to know that we understand that it is focusing in specifically on the ones that play sports. All right, so I want you to take some notes because I'm going to just ignore all of those boxes and we're going to show 2 specific ways to do these. Once again, if you want to use the Post-it notes that are back on my desk, you are more than welcome to use the Post-it notes. That's why I have them. So the first process, I find my ratio and I write it down. This is the process that we have been doing for the first 4 lessons. I'm going to put it equal to, now notice that we have the PS, that is the group that plays sports. And I have the total, which is down at the bottom, so that's the total number of students for this particular question. So if that's my total and my ratio, and I have 3 out of 5, then I have to look at my total or the next piece of information given in the word problem. So I know that the total has to be equal to 525 when I'm done. Once I do that, then I have to ask myself, well, what am I multiplying 5 by to get 525? Well, if we didn't look at what we had just explained on the previous slide, then the way we find that is we get our handy dandy calculator, we type in the math problem 525 divided by 5 to figure out what we're multiplying by. And when I hit equals, that tells me it is 105. So I show at the bottom of my ratio that I'm multiplying it by 105, which then tells me now I go to the top and I multiply by 105. So then I'm going to type into my handy dandy calculator 105 times 3, and that tells me my final answer is indeed 315. 315 what? 315 play sports. Now, I'm going to show you another way, and this is the way that generally I will remind you to set problems up, because this can be applied not just with equivalent ratios, but also with fractions and all sorts of math problems that we'll be doing throughout the year. All right, now I'm going to show you the second way. Once again, please take notes, because the second way, I'll come back to this all year long because it is a very systematic way of doing math problems, and we'll use this all year long because it will always work if I set it up correctly. So the first thing I need you to do is I need to label it. We're going to call it divide the loop, and I will ask you, Do you remember how to divide the loop? And you can go back to your notes. I'll also have this available for you on Canvas in the announcement so you can see both of these worked out. Write down these two notes and don't stress if you don't get them down before I move on, because you can pause this video as many times and for as long as you need to write down these notes. You get to set your own pace with my math videos, which is fantastic. You can also rewatch these as many times as you need. Here at school, at home, next week, 2 weeks from now when you do your math test, whatever you need to do to make sure you learn these lessons. It's why I do math videos, so you can work at your own pace, and then I can walk around and help you on anything you don't understand. But once again, if you need help, I expect to see the notes that I've asked you to take during the lesson. All right, so the two notes that we write down. Step one is that we're going to loop the diagonal numbers and multiply. And then step two is we're going to divide by the lonely number. Now that doesn't make any sense until we actually work it out. So that's what the rest of the note's going to be, is the math work. So when I set it up, I know I have my ratio or my fraction, and I know it's going to be equal to an equivalent ratio or fraction. In this case, we do have playing sports at the top and we have the total at the bottom. So I need to take my total students and put it at the bottom of the second fraction. We're missing the top. So that's where these two steps, once I have it set up, that's where these two steps come in. I'm going to loop the diagonal numbers and multiply. Well, I only have two numbers that are diagonal to each other because a question mark is not a diagonal. So I'm going to loop the 525 and the 3, and I know I'm going to multiply. So pick up your handy dandy calculator and you type in 525 times 3 equals, or you can do it the other way, 3 times 525 equals, because multiplication and addition can be done in any order. And I'm going to get 1,575. Step 2 tells me then I'm going to divide by the lonely number. Well, the lonely number is the 5. It's the one part of the two fractions or the two ratios that doesn't have a loop around it. So I'm going to take my 1575, I'm going to take my number that I found, my product in my multiplication problem, and always divide it by the lonely number. So I'm going to divide by 5. So then I just go through my steps of division. Will 5 go into 1? No. Will 5 go into 15? Yes. How many times? Well, if you don't know that 5 will go into 15 3 times, then all you have to do is type into your calculator the number you're looking at inside the division box. 15 divided by the divisor on the outside of the box. So 15 divided by 5 tells me it's 3. Then I show, well, then that means that 3 times 5 is 15, and I have no remainder. So I bring down my 7. Will 5 go into 7? Yes. How many times? So let's say you don't know. So in your calculator, if you type in, and I would like you to do this so you can see what I'm going to say on many of my videos, I'm going to type in 7 divided by 5 equals, and that's going to give you 1 followed by a whole bunch of decimals. I call that 1 and stuff because I don't care about the stuff that comes. What I need is the 1. If I know it goes in 1 time, then I can do 1 times 5, which is 5. The stuff just isn't going to be used. I always look for that whole number. Now I can do my subtraction. 7 minus 5 is 2. I bring down my next number, which is 5. And then I'm going to ask myself, how many times will 5 go into 25? Well, 5 goes into 25 5 times. So we end up with our answer by just doing that setup. 315. Notice it's the exact same thing. So this image is going to be on Canvas on announcements for you to go back and look to, and any time that you need to, or you have this video from now until the end of May. All right, so let's look at some more examples then. All right, so here we have, it says 2 out of 3 randomly selected students in Mrs. Mason's class at Heritage Middle School prefer cats as a household pet than any other pet. If there are 750 students at Heritage Middle School, how many students can be expected to prefer cats as a household pet? And then they have all of these boxes and you have to do all that work, but I'm going to say, nope. I'd get some extra paper on the side. You can do post-it notes, whatever, but I want you to work it out in the two ways that we just did. Okay, so we're going to look at the setup that we have, 2 out of 3. And then that's where I have to start thinking, well, what does 2 out of 3 look like? right? So 2 out of 3 looks like a ratio 2 to 3. And then I have to wonder, well, what are we comparing if we're talking about 2 out of 3 or 2 to 3? And then I have to look through the information. So we're looking at the ones that prefer cats compared to other pets. So I start to set up my ratio and my labels so that I know what my fraction is that I'm going to use. And then I have to see the rest of the information. If there are 750 students, so that is my total. So if I know that there are 750 total students, and I'm looking for how many students can be expected to prefer cats, then that's going to be my second numerator that I don't know. So I have to start with 2 to 3. So 2 prefer cats, 3 prefer other pets, and I have a total of 750 students. So we set it up as my equivalent ratio as we did in lesson 1, 2, 3, and 4. That's going to be the first time we work it. Once again, we're going to work it both ways so we know both of these processes. So then I have to ask myself, well, if I know it has to be equal to 750, then what am I multiplying 3 by to get 750? Well, you get your handy dandy calculator and you type in, once again, backwards, 750 divided by 3 equals, and that tells you 250. So I know I'm multiplying the bottom number by 250. Therefore, I have to, hopefully you thought, multiply the top by 250. And then I take 2 times 250 on my handy dandy calculator, and that tells me that's 500. So we're finding out that we would expect 500 people or 500 students out of the 750 students to prefer cats. The second way is we're going to divide the loop, right? So once again, I want you to do this both ways so you know these processes. We're going to follow those same steps that you wrote down on the Post-it note or in your notes in a different place. We're going to start with looping the diagonal numbers and multiplying and then dividing by the lonely number. And I have to start by setting up the exact same way. I know I have the ratio of 2 to 3, and it's equal to something over 750. My two numbers that are diagonal to one another are the 2 and 750. So I multiply those. I type into my calculator 750 times 2, and that equals 1,500. Then I'm going to divide by the lonely number, which is a 3. So inside my division box is my product of 1,500 dividing by 3. Will 3 go into 1? No. Will 3 go into 15? Yes. How many times? Well, if you don't know, then you take 15 divided by 3 and you find out that's 5. So 5 times 3 is 15 with 0 as my remainder. Now, I see 2 more zeros. So if I say, well, those aren't important, then we're saying the answer is 5. And we already found that the answer is 500. So once again, anytime I bring something down in a division problem, I have to bring something up to hold that place value. I brought down a 0, so I'm asking myself, how many times will 3 go into 0? 0 times. And then I have another 0. How many times will 3 go into 0? 0 times. I'm reviewing that because there are some of you who get to me in 6th grade, you didn't get that before. You didn't get it in 5th grade, you didn't get it in 4th grade, you can't figure out why you're constantly getting your division wrong. So make sure you understand that process and go back and review this as many times as you need to. Notice that we end up with the exact same answer of 500, so we know that we did that correctly. All right, so we're ready to do it. Here is your math problem. So you have questions 2, 4, 6, 8, 10, and 11. I gave you a hint on question 11. Okay? And I tell you at the top of the paper that the image is going to be on Canvas. So if you need help while doing it, please ask. But use your time wisely. This is less than the first section of math, so you'll be able to get it started, probably get 1 or 2 questions done before it's time for lunch. But please work and use the time I'm giving you. And then know that I'm here to help you if you're really trying.